Welcome to ChemPlus. Welcome to ChemPlus. Today we want to look at the rate of nucleophilic substitution. You might already have covered haloalkanes. They undergo nucleophilic substitution. You can see your nucleophile, this nucleophile there. What is a nucleophile? An electron pair donor. It attacks this positively charged center. And why is this carbon halogen bond polar? Why is it polar? It is because the chlorine atom is more electronegative. Now, before we look into the rate of nucleophilic substitution, we want to classify halogens. We've got haloalkanes, haloalkanes. The first one, this one here, you can see that this carbon to which the halogen is joined is only attached to one other carbon atom. So we call that primary. The second one, the carbon to which the halogen is attached to two other carbon atoms. So it's a secondary. And the third one, the carbon to which the halogen is attached to three other carbon atoms. So it's a tertiary. This is very important if we want to look at the rate of reaction. Now then, if we have fluoroethane and iodoethane, which one gives a faster reaction in terms of nucleophilic substitution? Pause the video and think. Right, for this one, we got to look at the strength of the C-halogen bond, and we will notice that the CF bond is 485 kilojoules to break that bond, the bond enthalpy, and the CI bond is 239. So all compounds having the CI bond give a faster reaction compared to the CF, compared to the CCl, or compared to the CBr. Now, this is not, bond strength is not the only factor. The carbon halogen bond is not the only factor that affect the rate of reaction. Other factors like whether it's primary, secondary, tertiary also do affect. As we can see from this chart here, the rate of nucleophilic substitution increases as we move from primary to tertiary. We will explain why. You can see that this is a primary haloalkane and is the slowest, and this is a tertiary haloalkane and it is the fastest. Now then, if we've got a primary haloalkane, like this is chloroethane, this is how nucleophilic substitution takes place. To begin with, that C-halogen bond is polar. Why? Because the chlorine is more electronegative. You've got your nucleophile that you can see the OH minus with a lone pair of electrons there, and it attacks the positive center. And as that happens, the electrons being shared on the carbon halogen bond move to the chlorine. This is considered as one step. As this attacks, this bond breaks. This attacks this bond. That happens at the same time, and that's your nucleophile, and we form that product plus that. That's why it's called nucleophilic substitution, because we've substituted the halide there. The curly arrows shows the movement of electrons, in this mechanism. Now then, in tertiary haloalkanes, it's a different story. The C-halogen bond breaks first on its own. It breaks first on its own to form this product here. What do we call this one? What do we call this product here with a positively charged sign? It's called a carbocation. Now, once the carbocation is formed, your nucleophile will attack the carbocation. Now, this is a two-step reaction. The first step is slow, and the second step is very fast. Right? This explains why these tertiary haloalkanes give a faster reaction, because this first bond breaks on its own, and once you form a carbocation, your nucleophile quickly comes in and attack. Now then, in primary haloalkanes, this happens. This is considered to be one step. As the nucleophile attacks the positively charged center, that carbon-halogen bond breaks. Now let's look at your tertiary haloalkanes. That's an example of a tertiary haloalkane. We can see there's a methyl group there, there's a methyl group there, there's a there is no room for your nucleophile to attack the positively charged carbon atom there. The nucleophile cannot do that. If you have a nucleophile there, it cannot attack that positively charged center. That's why the tertiary haloalkanes, they've got a different mechanism. First, the haloalkane breaks down to form a carbocation, and once the carbocation is formed, the nucleophile attacks. Speaking from inside the cup, this is King of the Classroom signing out. Yo!